Hello everyone, this is functions and graphs. I've selected some past paper questions which are different and should be important for the upcoming November session. So question number one, express this in the form of converting the square where a and b are constants. So part one, I'll just do it over here. We have 2x squared minus 12x plus 11. You can take 2 common, x squared minus 6x plus 11. You have 2x minus 3 whole thing squared minus 3 squared bracket plus 1 plus 11. If you can open the bracket, you get x minus 3 squared minus, now this is negative 9. So because 3 squared is 9, 9 times 2 will give you 18. So that's going to give you negative 18 plus 11. So 2x minus 3 whole thing squared minus 18 plus 11, that's going to give you negative 7. So that is the answer to part A, which is 2 bracket x minus 3 whole thing squared minus 7. Part 2, the function is f is defined by this for x is less than or equal to k. That's a really important concept for part 2. This is important. If you know it, it's good. If you don't, you can have a look over here. So your graph is going to be like this. The coefficient of x squared over here is positive. So we know the graph is going to be a parabola like this. And it's going to be upright like this for positive coefficient of x squared. So if we need to draw this, we have x0, x0. We get the y-intercept as 11. So it's going to be 11. And we'll get the turning point from here, which is 3 comma minus 7. So the turning point we extract from here, from the completing the square, would be 3, and y would be negative 7. So that's 3 comma negative 7. And 3 comma negative 7 would be, let's suppose, it's right over here. So we can have this as negative 7, and we can have this as 3. So we draw a curve passing through this like this. So that's our curve. Now it says state the largest value of the constant k for which f is a one-to-one function. If it's a one-to-one function, that's the only case when it's going to have an inverse. Otherwise, it can never have an inverse. So to have an inverse, to get an inverse from a quadratic function, we make it a one-to-one function. So that means we are considering one side of the graph. Either we are considering from the line of symmetry. So that's the line of symmetry that we have over here. So if we draw a straight line from the line of symmetry, we are either considering this side of the graph, which would be the negative side, and this is the positive side. So your right hand side is always the positive side, your left hand side is the negative side. I'll tell you what it means. These are the positive plus and minus signs you have to take into consideration once you're finding the inverse of a quadratic function. Okay, so now it says the largest, whether it says the largest value or it says the smallest value for the constant k. K value will always be the line of symmetry, the x value of the line of symmetry. So over here it is, so what we have to find k. So the k would be 3. So the largest value for k would be k is equal to 3. It's always going to be 3. Okay, so that's where it's splitting the graph into 2. For this value of k, now which is 3, find an expression for f inverse and state the domain. Why are they saying this value for k? Because we have considered this x being less than and equal to k. That means x is less than or equal to 3 because we got k as 3. So in this case, it has to be less than or equal to 3, and it says the largest value. So that means we are considering the left hand side because that is where the x value is largest over here. So we are only going to consider 1/2 of the graph to have an inverse, which is going to be this side of the graph. And so once we're considering this side, we are going to take negative sign into account, and I'll tell you how we're going to do that. So we have the function y is equal to, we got the completing the square as 2x minus 3 whole thing squared minus 7. Now we find the inverse of this, so that's y plus 7 divided by 2 is equal to x minus 3 whole thing squared. So you take square root on this side, square root on this side, and you will get plus minus. Square root of any number is just plus minus. So that's where the plus minus comes in. Now you have to make x the subject. So x is equal to the negative 3 goes on the other side. You get negative, instead of negative 3, you get positive 3 plus minus under root of y plus 7 over 2. So your final answer would be, we have to find f inverse. So that's how I have f inverse, which is 3. Now, since it's on the left-hand side, this is where the negative sign comes in. So instead of taking plus minus, we just go ahead with the negative sign. Since we know we are taking the left-hand side, if we were to take the right-hand side, we would have taken the positive sign. X plus 7 over 2. That's our f inverse. Now part 4. With k now taking value of 1, find the largest value of the constant p, which allows the composite function f of g to be formed. This is a really important part for composite functions. This is part 4, and this was part 3. For part 4, for any composite function, please do remember that if it's f of gx, like it says over here, f of gx, composite function. So with k now taking the value of 1, so if you remember, x was less than or equal to k, and now k takes a value of 1, so that means x is less than or equal to 1. That is the domain. That's the domain of fx. That's the domain of fx, because this is the x value. The x value is the domain. The domain of fx should contain, or should have, the range of gx, and this gx will take the whole function of gx. So the gx function over here is given as, gx function over here on the top is given as x plus 3. So we have x plus 3 less than or equal to 1, which is the domain of x, and we get the x value is x is less than or equal to 1 minus 3. So x is less than or equal to minus 2, negative 2. And that is our answer. Now we will move on to the next one. Now the next question. November 2004, paper 1, question number 6. This is an old question, but I've taken this because I found this very helpful, and this should be interesting. So this is an important question for the upcoming November session. The function fx is such that you have the function fx is equal to 5 sine squared x plus 3 cos squared x is defined for the domain from 0 to pi. Express fx. So the first part is you have to express fx in the form of a plus b sine squared x only, stating the values of a and b. So if you notice this and you compare, we have to express the given expression in terms of this. Over here, in this expression, we have sine squared x and we have cos squared x. And in the final one, we just have sine squared x. So that means we have to use the identity, which is sine squared x plus cos squared x is equal to 1. And we need to replace this cos squared x by this whole cos squared x would be 1 minus sine squared x. We will use this. So that's what we do over here. We have fx is equal to 5 sine squared x plus 3, 1 minus sine squared x. If you open the bracket, we get 5 sine squared x plus 3 minus 3 sine squared x. So 5 sine squared x minus 3 sine squared x will give you 2 sine squared x and plus 3. So that is in the form of this, or if you just need to write the constant first, so we can have 3 plus 2 sine squared x, and like the question says, stating the values of a and b. It says right over here, stating the values of a and b. So in this case, a would be, you have 3, a is 3, and b would be 2. So that's the answer to the first part. Hence, find the values of x for which fx is equal to 7. It says hence. This means it's a continuation of the first part. So the first part we got this, so we are going to use this answer. So we have part 2. Part 2 we got as fx is equal to 3 plus 2 sine squared x, and that is equal to 7x, 7 sine x. So we have fx is equal to 7 sine x, 7 sine x. So now we just equate them. So we have 3 plus 2 sine squared x is equal to 7 sine x. Why we are doing this? Because this has a value y and this has a value y. So we are equating the two y's, the values of two y's. Like we equate any two regular equations. So we have 2 sine squared x on this side. We bring the negative 7, the 7 sine x on this side. We get negative 7 sine x plus 3 is equal to 0. Now we need to do quadratic equation and need to find the factors and do middle term breaking on this. So that's 2 and 3, that's 6. So we can get this as 2 sine squared x minus 6 sine x plus sine x, and that would not be plus, that would be a minus. So that's also minus, because minus will give you minus 7x, and then minus times minus will give you positive 6x squared, 6x sine squared. So that's this. Now we can take 2 sine x common, so we'll be left with sine x minus 3 minus 1. We have sine x minus 3 is equal to 0. We get 2 sine x minus 1, and we get sine x minus 3 is equal to 0. So we equate both of them equal to 0. We get sine x is equal to half, and we get sine x is equal to 3. Now sine inverse, so x is equal to sine inverse of 3. There will be no solution for this. And sine inverse of x, sine inverse of x, sine inverse of 0.5, I think that's going to be pi by 6. It has to be in radian mode. So please do check your calculator, it has to be in radian mode. So sine inverse of 0.5, that gives you pi by 6 here. So that's x is equal to pi by 6. This is a positive value, so we go for the other quadrant too. So we have A, S, T, C, just for your information. So this is theta, this is 180 minus theta. And since this is in radians, so that's going to be pi minus theta. So we got the first answer as pi by 6. The other one would be pi minus pi by 6. which is 180 minus theta. So if we can do pi minus the answer that we got is 5 over 6 pi. This is 5 over 6 pi. So the two values that we are getting would be pi over 6 and 5 pi over 6, if that falls in the range. So let's just go and check the range again. From 0 to pi, so yeah, that's fine. That should be in the range. Now state the range of f. That is in range because 0 to pi, so this is 5 over 6 pi is less than just pi. State the range of f. Now we have to state the range of f. So for the range of f, we have this formula. We have the equation. Now this is really important for the range of f. This is different because this is squared quadratic function. This is a quadratic trigonometric function, which is, I'm going to use this, which is given to us as 2 sine squared x plus 3. So we have the function as fx is equal to 2 sine squared x plus 3. That's what was given to us. So we proved that this original function can be written as this, like what we did in part 1, and we got the answer as this right over here. So I'm going to use this. So I'm saying that fx is the same thing as 3 plus 2 sine squared x. Now I'm going to find the range from here. Now this is a trigonometric function, but this has a square over here. So we are going to start with our normal fx function. The normal fx function will take values from here to here. And since this function is 2 sine squared x plus 3, this is what we have to get. So we start with the basic and we say let fx be only sine x, that's all. So when this is sine x, so if this is sine x, we have the range from -1 to +1, because that's how the sine x graph is. We have the sine x graph from here to here. That's -1 to +1, and that's our sine x graph. So that's the range for sine x. Now, since sine x is squared, so the first positive squared number that we get would be 0, and that's the domain. So that's good. And so if we get 0, we plug in 0 in this equation, sine squared 0, we will get 0. So we are getting this as 0. So that's really important. The -1 becomes 0 because that's the first positive squared number, and we have to get positive squared number because this is sine squared x. So now we have sine squared x, so that's going to be multiplied by 2. So that's multiplied by 2. So both sides will be multiplied by 2. So 0 times 2 will give us 0. 1 times 2 will give us 2. And then we have finally 2 sine squared x plus 3. We're adding 3 to both sides. So that's going to be 2 plus 3. And this is going to be 0 plus 3. So our final range for this would be 5, which is 2 plus 3, that's 5, and 0 plus 3, that's 3. So that should be the range for the fx function. Now let's go on to the next one. Over here it says, this is November 2015, paper 1-2, question number 8. Again, I found this a bit different from the rest of the questions, so I've selected this as one of the important questions. So part 1 is going to be, you have the function fx is equal to x squared plus ax plus b as your function, where a and b are constants. In case where a is 6 and b is -8, find the range of f. Okay, so we have fx is equal to, we have a as 6, So this is x squared plus 6x, a is 6, and b is minus 8. So that's minus 8. That's what we have. So that gives us a quadratic equation. And it says find the range of f. So from a quadratic equation, how do we work out the range? The only way we can work out the range from a given quadratic equation is to do the completing the square on this and have this in the form of a x minus b whole thing squared plus c. Have it in the completing the square form. Only then we can tell what the range is depending on this c value. So we do completing the square on this, we get fx is equal to x squared plus 3 squared. So that's just going to be x. So we get x plus 3 squared minus same thing over here. So that's squared minus 8. We get x plus 3 whole thing squared minus 9 minus 8. So that's x plus 3 whole thing squared minus 17. So the function fx function would always be greater than, since this is positive, so it's going to have a shape like this. It's going to have a positive shape. It's going to be like this. It's going to have a minimum point. And since this is 0, this is 0, if we make these two 0, we get negative 8. So it's going to intersect at negative 8. So let's say negative 8 is right over here. So that's the point of intersection at negative 8. And the minimum point would be negative 3, negative 7. So negative 3 and negative 17. So it's going to be somewhere over here with negative 3. And let's say this is negative 17. We do not have to sketch this, but I'm just doing it just to make you understand how we get the range. So since this is the minimum point, so it's always going to be above negative 7. So we're going to say the range is fx is always greater than or equal to negative 17. That's how we get the range. Part 1 done. Part 2, in case where a is 5, the roots of the equation fx equal to 0 are k and minus 2k. Where k is a constant. Now this is a different question. So I haven't seen much questions like this, like these. So in case where a is 5, so we need to have a as 5. So we will just write down the equation again. A is 5. So okay. So this is part 2. And we have the function as fx is equal to x squared, and it says a is 5, so we have 5x plus b. Doesn't say anything about b. It says it has two roots, x is equal to k and x is equal to negative 2k. Let's just double check. So in the case where a is equal to 5, the roots of the equation fx equal to 0, and that means this is a factor. So x is equal to k and x is equal to negative 2k. This is a constant. Find the values of b and k. Okay, so that's all we have. So we have x squared plus 5x plus b is equal to, these are the two roots. So if these are the two roots, that means these are the two roots where this is intersecting the x-axis. So wherever the curve is intersecting the x-axis, let's suppose it's like this. So these are the two solutions. These are the roots. So if we do reverse working, so it would be x minus k as one factor and x plus 2k as the other factor, and both of them are equal to 0. So if we multiply them out, we get x times x is x squared, x times this is plus 2xk, this time this is minus kx minus 2k squared. This is what we're getting. And if we can add them up, so this is x squared plus 2xk minus kx would just give us kx. This is plus, this is minus 2k squared. So that is a quadratic equation that we're getting, and we already have this as x squared plus 5x plus b. So we are going to do comparing the coefficients of the two quadratic equations that we have, because they are the same. They are equal. So Now we are going to compare the 5x with kx, and we get k value as 5. Then we're going to compare the b value with minus 2k squared. So the b value is the term which has no x. So the term which has no x over here is just this, minus 2k squared. So b is equal to minus 2, and we got the k value as 5. So 5 squared is 25. So b should be 25 times minus 2. That should be minus 50. So b is equal to negative 50. Let's just have a recap on this. So that's 25, 5 squared is 25, 25 times 2 is 50, minus 50, yeah, that's fine. So these are the two values that we get for part 2. Part 3, show that if the equation f x plus a is equal to a has no real roots, then this. So x plus a, now this part 3 is also quite different from the rest of the normal function questions or quadratic questions in the past. I haven't seen much questions like this, or maybe I haven't seen any like this. So this is f is x plus a is equal to a. So we have f is x plus a is equal to a. So we have the equation as fx is equal to x squared plus ax plus b as the original one. So we're going to substitute the values over here in this equation. So this is the value of x, right? So x is now going to be replaced by x plus a. So we have the equation as this x squared, and this whole equation is equated to a. So we'll have x plus a, which is squared, so that's x squared, plus a, and then x again, which is x plus a. So ax, so x squared plus ax plus b, and the whole thing is equal to a. So we get this as x squared plus 2ax plus a squared. If you open the bracket, and this is ax plus a squared plus b minus a is equal to 0. So I'm just simplifying this. So that's x squared, and we get 2ax and ax. So that's plus 3ax. So that's 3 plus ax, not a. That's 3ax. Yeah. So I'm done with this, I'm done with this, and I'm done with this. So a and a, that's gives me 2a squared. So that's 2a squared, and that is plus b minus a. That's all I get. So now the question says, if we go back to the question, says show that this is equal to this. That's what we have done. Has no real roots. Then a squared is equal to that thing that we get. So that means a squared we have to make the subject when this has no real roots. So no real roots means b squared minus 4ac has to be less than 0. So this is what we have to apply in this. So considering the values of a, b, and c, a would be 1. B would be the coefficients of x, which is 3a. So that's b squared minus 4. A is just 1. C will be everything which doesn't have x. So that's 2a squared plus b minus a. This whole thing is less than 0. This is 9a squared minus 4 times 2 is 8. 8a squared plus 4 times this is 4b. So that's minus 4b minus 4b plus 4a is less than 0. And we have to make 2a squared the subject. A squared the subject. So a squared the subject. So, okay, so that's 9a squared minus 8a squared. So that gives us a squared. Take these two on the other side, minus 4b on the other side, so we get positive 4b, plus 4a on the other side, so we get minus 4a. And we get a squared is less than 4 common b minus a, and that is shown. So that's done. And that's what we had to show. A squared is equal to this. So that's done. That was the third question. Yeah, and then we will do this one. Okay, so now we're going to continue with this. So we're going to continue with this. Let me just fix this. Okay, sorry. So this is question number 6. This is where all A and B, the values are missing, and the X value and the output is given. And we have to figure out the values of A and B. So we have to work out the values of A and B. And part A, this is important, a very good question. So an important one for the exam in order to for you to get it right. If this comes, you should get it right. This should be easy marks. So you have the question as fx is equal to, we're given a plus b sine x. Since we have given this x is the input as 1 over 6 pi, and we get the result as 4, and the other one is half pi is equal to 3. So this is where we get the two equations from, and we work out the values of a and b. So the first equation that we get would be, we have a plus b sine, and this is sine x. So sine, we get 1 over 6 pi, so that's pi by 6. That is equal to, we equate that equal to 4. So if we do this, we get a plus sine pi by 6 will give us half, so that's half b. So that's a plus half b is equal to 4. So we can rewrite this equation in the form of multiply the whole equation by 2, we get 2a plus b is equal to 8. So that's our first equation. The second equation we get from the second one, second coordinates that we had, which was f pi by 2 is equal to 3. So we make the second equation from here. So we have this as a plus b sine pi by 2, and the whole thing we equate equal to 3. So we have a plus, now sine pi by 2, that is just 1 because that's sine 90. So that should give us just 1. Yeah. Yeah, that's going to give us 1. That's right. So that's a plus b is equal to 3. So that's the second equation that we get from here. Now, equation number 1 and equation number 2, if you solve them simultaneously, you should be getting the values. This is 2a plus b is equal to 8, and this is a plus b is equal to 3. So you solve them simultaneously. You can do it by elimination or substitution, your choice. So minus minus, so that's just going to be 2a minus 8, that's just going to give us a is equal to 8 minus 3, so that's going to give us 5. So we get a as 5. So we get a as 5, so we get b as what? So that's a plus b is equal to 3. So a is 5, so b would be minus 2. Let's see, we have a as 5. We got the answer as a as 5 and b as minus 2. That's the answer to the first part. Now, in the second one, it says evaluate f of f0. f of f0 means f of f0. So first, we have the function with the values of 5 in this. So what was the function again? We had a plus b sine x as our function. So in this function, we're going to replace the values that we got. We got the values of a and b. So a was 5, so we can write this as 5 minus 2 sine of x. Now the first function takes a value of 0. So that's our first input. So we take this value of 0. So we will get sine 0. So we get 5 minus 2 sine 0. Now sine 0 is 0 times 2 will give you 0. So we just get 5. So that means f of 0 just gives us 5. So now that is what we are getting for f of 0. So this value gives us 5, and that has to be substituted in the f function again. So we get f of f0 as, so that's function within a function. So first you're substituting the value of x as 0 in the f function, you get 5. Then what the result that you get 5, you're going to substitute that result 5 in the function of f again. That's why it's known as f of f0. So you have 2, now sine, and this is 5. So if you work this on your calculator, you would be getting 6.917. 6.917, and that would give you approximately 6.92, 6.92. 3 significant figures. So that is how you evaluate f of f0. Now the last one, the function g is defined by c plus d sine x, c plus d sine x, and the range is given from -4 to 10. This is the last one. So the function is given as c minus d sine x, c plus d sine x. Okay, c plus d sine x, c plus d sine x, and you're given the function is gx, not fx. So it's from here till here. So we can have this as g. It doesn't really matter. So that's gx. Okay, so we can just quickly erase this and have this as g. Okay, this is g. That's fine. Now, the highest value is 10, so that's the maximum value. We get the maximum value, we get 10, and that formula for the maximum value is you do c plus d. You do c plus the value of d. So c plus d should give you 10, and the minimum value you get is, the minimum value is -4, and the formula you do that for that is c minus d. C minus d. Yeah, that's right. C plus d and c minus d. So now what can we do? We have this as c plus d, and if we can simplify this simultaneously, that won't cancel out. So we can cancel out the d's and we can work out the values of c's. So this cancels out elimination. You get this as 2c, and you get this 10 minus 4, that gives you a 6. So c is equal to 6 over 2, so that's 3. You get c as 3. Once you get this as 3, you can have 10 is equal to 3 plus d, and you can work out the value of d as 7. So you get c as 3 and d as 7. That's the answer. Now, the most important thing is, if you have a sine graph, like supposing like this, you have a sine graph, and you need to work out the maximum and minimum, and there is an equation given, like the equation that we have right now, and let's just use the values that we got in our equation. So we have gx is equal to c plus d sine x was what we were given, and we worked out the values, and we got the c value as 3, and we got the d value as 7. So if I substitute these values back in this, c is 3, D is 7 sine x. Now, if I work out the range, I should be getting the same range that was given to me, right? Which was from -4 to 10. Now, how do I work out the range? Because that's what I've done over here to generate these two equations and solve them simultaneously. If you're wondering where did I get these two equations from, so that's what I've done. So I'll show you how to get these equations. So this is the maximum value. The maximum value can be calculated by this value, which is right over here. That's the C value. So that's this value plus this value. So it's plus basically C plus D. That's what we have done over here. See, C plus D is equal to the maximum range that we were getting. So C plus D is 10. So that's the maximum you get, which is 10 right over here. In order to work out the minimum range would be C minus D, would be C minus D. And over here, that would be C is 3 minus D is 7. So 3 minus 7 gives you -4. And that's the minimum you get. And that is right over here. So that's minimum right over here. That's maximum over here. That is how we generate our range from the range of maximum and minimum for any graph. It doesn't really matter if it has to be sine graph or cos graph or tan graph. You can do this. And that's how you get to the answer. So there are a couple of more questions. I will be making another video and we'll be covering those questions in those videos. So stay tuned for the next upcoming video. Thank you.